All right, on tonight's episode of Python Papi, we're back inside of our artificial intelligence course, and we're still inside of our uncertainty 2 module. Let's have a look at what we went over tonight. Now, tonight we will be discussing the topic of uncertainty over time. This will explore what we can do to deal with uncertainty over a period of time. We will also be dealing with the topic of what we can do when values change over time. This can come up in the context of weather. For example, when we have sunny days and cloudy days, we would like to know things like not just the probability that it's raining now, but what is the probability that it rains tomorrow or the next day or the day after that. To do that, we are going to produce a slightly different type of model. Here, we are going to have a random variable, not just one for the weather, but for every possible time step. We can define time step however we like. So we use days as our time step for this example. So we can define a variable called x sub t, which is going to be the weather at time. And this would be that example right here, x sub t, weather at time. When we are trying to do this inference inside of a computer, when we are trying to reasonably do this sort of analysis, it's helpful to make some simplifying assumptions. Some assumptions about the problem that we assume are true to make our lives a little bit easier, even if they're not totally accurate assumptions. If they're close to accurate or approximate, they're usually pretty good. And the assumption we are going to make is called the Markov assumption. Let me get that example for you here. And the Markov assumption is the assumption that the current state depends on only a finite fixed number of previous states. So let's go down a little bit further and see exactly what it's saying. So the current day's weather depends not on all the previous days' weather for all of history, but the current day's weather we can predict just based on yesterday's weather, or just based on the last 2 days of weather. How many number of days we specify is how many days we'll go back. But usually we are just going to deal with just one previous state, which helps to predict this current state. And by putting a bunch of these random variables together using this Markov assumption, we can create what is called a Markov chain. Now, a Markov chain is a sequence of random variables where the distribution of each variable follows the Markov assumption. And we're going to leave it there for tonight. We did take a lot of notes. We did get pretty far. And we did do a few more examples that got in detail, but it'll be too long of a video to go too in detail with everything. So we'll leave it there for tonight, but we will pick it up tomorrow. But as usual, this is the Python Poppy. You guys stay Gucci.